Hey everyone, just want to welcome you to week 4, module 4 for ME14, Mechanics of Solids. In this module, we're going to take a look at torsion. In particular, we're going to take a look at circular shafts and torsion. Then we'll spend some time with angle of twist in the elastic range. Then move on to some statically indeterminate shafts and the design of transmission shafts. Now, a couple of bookkeeping items for this week. You have your quiz number 4 that has been posted to Blackboard. Reminder, this will be due on Friday by 4 p.m. on the 26th. You also have homework number 2 has now been posted to Blackboard and released, and then you'll have 1 week to complete this. It'll be due on Monday, the 1st, by the end of the day. Now, just a reminder, I do have office hours scheduled on Wednesdays from 9:30 a.m. till 10:30 a.m. If these times don't work for you, please get a hold of me, send me an email, a message, or a chat, and we'll find a time that works well for both of us. So as we get into Module 4, we'll be looking at torsion, in particular taking a look at shafts, and within shafts we're going to take a look at the angle of twist, indeterminate shafts, and some transmission shaft design. So in this module, we're going to consider structural members and machine parts that are in torsion. We're going to go ahead and analyze these, take a look at some practical applications where the stresses and strains in the members of the circular cross section are going to be subjected to twisting couples or torques. So within this module, we're going to introduce the concept of torsion in structural members and machine parts. We're going to define shearing stresses and strains in circular shafts that are going to be subjected to torsion. We're going to define the angle of twist. We're going to do this in terms of applied torque, geometry of the shaft, and the material. We're then going to go ahead and take a look at the use of torsional deformations to solve indeterminate problems and discuss again what indeterminate problems are. Then we're going to take a look at the design for shafts for power transmissions. And from there, we're going to review stress concentrations and how they're included within these torsion problems. Describe the elastoplastic response for circular shafts again. And then analyze torsion for non-circular members. And finally, we're going to move on to defining the behavior of thin-walled hollow shafts. Now, if you're relating back to the chapters in the book, we're going to begin Chapter 3 with this, and your readings here for this section are going to cover Chapter 3, Sections 1 through 4. And again, I would suggest that you read ahead again for next week for Module 5 to continue on in Chapter 3 with your readings ahead of time. So for Chapter 4, we're going to break this into 2 different modules. The first module, Module 4.1, we're going to look at torsion, in particular circular shafts and angle of twist. So this is going to relate back to sections 3.1 and 3.2 in your textbook. Within this module, what we're going to do is take a look at some of the key theories, the equations that we'll be using, some applications, some practical applications for these key equations, and then from there we're going to go into some problem solving and go through my hand solution for a few different problems. Then we'll move on to the second section, Module 4.2, still continuing on with torsion of shafts, this time taking a look at statically indeterminate and transmission shafts. So if you relate back to your textbook, this is sections 3.3 and 3.4 in your textbook, where 3.3 is statically indeterminate shafts and 3.4 is the design of transmission shafts. So within this module, we're going to go again and look at the key theories, some applications and key equations that relate to the theories and applications, and then go from there into some problem solving where we go through my hand solutions.